Hello all, welcome to Soumya Tutorials, Class BCA 5th semester, Cbcs syllabus. Concept is Analysis of Designing Algorithm. This is the session number 2. Chapter 1, Introduction to Analysis of Designing Algorithm. So last class we had discussed about the concept of what is an algorithm, what are the characteristics or criteria of an algorithm, and what are the algorithm specifications and the pseudocode conventions. So first, let me know about fundamentals of algorithm problem solving methodologies. So in this methods, it has the series of methods here: understanding the problem, ascertain the capabilities of the computational devices, exact and approximate solution, decide on appropriate data structure, algorithm design techniques, methods of specifying an algorithm, proving an algorithm's correctness, and analyzing the problem. These are all some of the methods of the fundamentals of algorithm problem solving. The first thing is that understanding the problem. Here, the first thing you need to do before designing an algorithm, first you should understand completely the problem is given. So first, you should read the problem description carefully and then ask the questions if you have any doubts about the problem. So this is, we can call it as the understanding the problem. Then we move on to the second method, ascertain the capabilities of a computational devices. So here it is intended for, there are the two different capabilities of a computational device. The one is an sequential algorithm. One more, it is an parallel algorithm. So what is a sequential algorithm? So in the sequential algorithm, instructions are executed one after another. So this type of algorithm is called as sequential algorithm. One more, it is a parallel algorithm. Here, some of the newer machines can implement the steps concurrently or parallelly. This we can call it as a parallel algorithm. So this is about this ascertain the capabilities of a computational device, either it is in a sequential manner or it is in the parallel manner. Then go to the third one, exact approximate solution. First, there are important problems that simply cannot be solved exactly for the most of their instances. So that second available algorithms for solving a problem exactly can be unacceptably slow because of intrinsic complexity. So there are the two solutions here. One is an exact solution, one more is an approximate solution. The next thing is decide on appropriate data structure. So in decide on appropriate data structure, so data structure, which means that data structure is a way of organizing and storing data in the computer system, so that what type of a data structure which are to be used for designing this problem. Then we move on to the next step here, algorithm design technique. In algorithm design technique, it has the two different types of a method. Either it is in the algorithmic form or it is in the flowchart form. So an algorithm design technique is a general approaches to solving a problem algorithmically that is applicable to variety of your problems from different areas of a computing. So that it is designing an algorithm by using the sum of the methods, like either it is in the flowchart or it is an algorithm. Then go to the next method, methods of specifying an algorithm. So there are two mainly options for specifying an algorithm. Either it is in the natural languages or it is in the pseudocode languages. So natural languages, that is in the concept of this is written in only in the English statements. In the pseudocode form, it is a mixture of the natural languages and also the programming languages like a constructor. Then go to the next one, proving an algorithm correctness. Once an algorithm has been specified, you have to be prove it is correctness. You have to prove that the algorithm yields is a required result for every legitimate input in a finite amount of a time. That is, a common technique for proving a correctness is to use a mathematical induction because an algorithm interactions is provides as a natural sequence of steps needed for such a proof. So that this is about proving an algorithm correctness. The last method is analyzing an algorithm. In this case, an algorithm is executed. It is used the computer's central processing unit to perform certain operations and its memory to hold the program and the data. Analysis of a programs and designing of an algorithm and performance analysis, it refers to the task of determining how much computing time and the storage an algorithm is required. There are the two kinds of algorithm efficiency. Either it is in space efficiency or it is in time efficiency. In the time efficiency, how much space algorithm has to be taken for a storage, and time efficiency, which means that how much time it takes to execute certain instructions. So these two are the sum of the algorithmic efficiency like space efficiency and also the time efficiency. So space efficiency, it indicating that how much extra memory it uses, and time efficiency, it indicated that how much time it fast algorithm. So these are all the sum of the fundamental stages of an algorithmic problem solving methods. Then go to the next slide here, linear data structure. The first thing is that what is a data structure? The data structure can be defined as a particular scheme of organizing related data items. A data structure is a way of organizing and storing the data in the computer system. This is a one more definition of an data structure. So data, which means that data is that any unprocessed items which are required to be a processing. So or a data are the raw facts which are required to be a processing. The data is either it is a raw material, either it is a text or it is a number or it is a any uh, audio files or it is any video files, we can call it as a data structure, which means that the way of organizing and storing. So both are combined together. A data structure is a way of organizing and storing the data in the computer system. So stack. The stack, it is an example for the linear data structure. So what is an stack? A stack is an ordered list in which all insertion and deletions are made at one end. That end, it is called top. A stack is an ordered list in which all the insertion and also the deletion are made at only one end. That end, it is called top of the stack. Operations of stack, it implies that if the elements are A, B, C, D and E are inserted into the stack, in order that then the first element to be removed, it must be E. Equivalently, we say that the last element is inserted into the stack, that element is first to be deleted. For this reason, the stack R, we can call it as that the last in, first out. Please. So that the stack, which is also called as last in, first out, because the last element to be inserted into the stack, that element is first to be removed. So that the stacks are referred to as an the last in, first out. So this is the diagrammatic representation of the stack. So in this stack, the first A element to be inserted, then B element to be inserted, then C element to be inserted into the stack, then D element is inserted into the stack, then E is inserted into the stack. So here the top which is incremented by the one by one elements are to be inserted into the stack. So here the last element is E, which is the first to be deleted. So this process we can call it as the last in, first out. The next is the representation of the stack using arrays. The simple way to represent a stack is using an one-dimensional array. So here is the stack. Within a subscript, you have to be mentioned 0 to n minus 1. Here, n is the maximum number of elements which are present in this stack. The first element in the stack, which is stored at the location stack of 0, and second element is stored at the location stack of 1, and ith element is stored at the location n minus 1. So here top is a pointer which points to the topmost element in the stack. So in the representation of the stack using arrays, we have to be checked there are the two conditions. The first condition is when the stack is an empty, and the second condition is that when the stack is an full. The first, to test whether the stack is an empty, here we have to check the condition that if the top is less than 0. When the top is less than 0, when this condition is become true, so that the stack is an empty. Then one more condition is that if the top is greater than or equal to n minus 1, when this condition is checked, it's checking whether the stack is a full. If the top is greater than or equal to n minus 1, when it checks the condition, if it is true, the stack is a full. So this is the diagrammatic representation of the representation of the stack using arrays. So in this diagrammatic representation, the arrays indexes are 1, 2, 3, 4, 5, and 6. The top, which is initially 0, when the first element is inserted, that is stored at the location 1, then the top pointer is incremented by the value 1. Then the one more element is inserted into the stack, then the top pointer is incremented by the value 1. So that the representation of the stack using the arrays, it has the two conditions. One is a stack is an empty, one more it is a stack is a full. So this is the two most substantial operations are either it is insertion or it is a deletion elements. The corresponding algorithms are here add, that is for an insertion, delete, that is for a deletion. So this is two algorithms or representation of the add and also the delete. The first algorithm is that algorithm add item. So this process we can call it as a push. Normally inserting an element into the stack, that process we can call it as a push operation. Algorithm add item. Here item is a parameter of this function. So then push an element into the stack. It returns true if the successful. When element are to be inserted into the stack, that process we can call it as a push. Pushing an element into the stack and it true if the successful, or else it returns false. Item is used as an input. The first, it checks the condition top is greater than or equal to n minus 1. When this condition is become true, the stack is a full. It returns a false. When this condition is become false, go to the else part. First, it increment the top pointer, then the item is inserted into the top. So when this process is executed, it returns the true. So this is, we can call it as an add. That is the pushing an element into the stack. The whole we can call it as insertion algorithm. The second algorithm is delete. Deleting an element from the stack. So here also the item has a parameter. So here pop the top of the element from the stack. If it is true, it is successful, or else it returns a false. The item is used as an output. The first, it checks the condition. If the top is less than 0, when this condition is become true, the stack is an empty. So that is return a false. Or else go to the else part. Take item from the stack pointer, that is the topest element from the stack. Then it is copied, that is to be deleted. Then decrement the top pointer. On successful, it returns a true. So this is an algorithm. We can call it as the deletion operation. So which is also called as pop the top element from the stack. So there are the two operations are performed here. One is the insertion, that is add. One more, it is a deletion, that is called delete algorithm. Then the second representation is linked list representation of a stack using the linked list. Another way to represent a stack by using the linked list. Here the node is a collection of data and link information. A stack can be represented using a nodes with the two fields. Either it is a data field or it is a link field. The data field of each node, it contain a item or an information in the stack, and the corresponding link field, it points to the next containing the next item in the stack. The link field, it, it is a field of a last node that is represented as a null. Here, examples of the linked list representation of the stack here. A stack with the items A, B, C, D, and also E in the order. The first, we have to be inserted A element into the stack. Then we have to inserting the B is element into the stack. Then we have to inserting the C is element into the stack. Then we have to inserting an element D into the stack. The last element is E is inserted into this stack. So this is a 5 elements which are insertion into the stack by using the linked list representation. In the linked list representation, first we have to creating the node. The node contains the two different part. The first part, it is a data field. Second part, it is a link field. The data field, it contains the information, either it is A, B, C, D, E, and link part, it is an address of the next node. This is an example of a 5 element in the linked list representation of any stack. So these two are algorithm for the linked list representation of a stack. It has two different types of operation. One is addition operation. One more, it is called deletion operation. So before going to these operations, first we have to creating the new node. A node, it contains the two different part. The first part, it is called as a data field. Second part, it is called as a link field. A data field, it contains information. The link field, it contains the address of a next, that is the link of a next node. So then we perform these two operations, addition and also a deletion operation. So in addition operation, first it checks whether the stack is full or not. So first it checks whether the stack is full, the insertion is not possible, or else then increment the top pointer, then we have to inserting the element into the stack. Then go to the deletion operation. First, it checks whether stack is an empty or not. If it is empty, the pop operation is not possible. Or else, then go to the copies, that the topest element from the stack, then decrement the top pointer, then the successful removing the element from the stack. This is a deletion operation. Thank you. If you like my videos, please do subscribe to my channel and click on the bell icon for the notification of a new videos. Thank you so much.